Okay, so today we're going to get into chapter 7, which is on conic sections and parametric equations. It was first discovered by Menaechmus. Okay, and Menaechmus was a mathematician from 375 to 325 BC. He discovered conic sections around 360 to 350. Now basically what happens, how a conic section is created, is you slice a double cone by a plane. So when we think about a double cone, we think about a cone with something inverted on top, and we're actually going to look at an example of this using the netbooks. And so there are 4 conic sections, and we're going to talk about all 4 of those. And then there are 3 degenerate conic sections. And so that's kind of important. The 4 conic sections that we're going to learn about are as follows. Okay? You have a parabola. That is the one that we're going to just start talking about today. We probably aren't going to do many examples. Then we have what's known as an ellipse. Now, hand in hand with the ellipse is what is known as a circle. And then we have what is known as a hyperbola. Those are the 4 conic sections. We have 3 degenerate conic sections. Those 3 degenerate conic sections are a point, okay, a line, and then 2 intersecting lines. Okay, a point, a line, and 2 intersecting lines. So real quick today, we're just going to do a basic activity. I want you to go to this website, illuminations.nctm.org/activitydetail.aspx?ID equals 195. Okay, so I want you to go ahead, go to that website, illuminations.nctm.org/activitydetail.aspx?ID equals 195. Now, for those of you watching the video, what I'm going to do right now is I'm just going to stop it. You can go to that website and investigate on your own. Okay, and I will come back again with the video. Okay, so we're back after looking at that website. And what we need to get down here is we need to get down what the general form of the equation of a conic section looks like. This is called the general form, similar to the general form for the equation of a line. Okay, general form for the equation of a line. Ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Now notice there is a qualifier here. A, B, and C cannot all be 0, because if they were all 0, you would have an x, a y, and a number. And so this would be the general form of a linear equation. So in order for you to get a conic section, okay, you could have A and B be 0, but C can't be 0. The biggest thing is all cannot be 0. And so now what we're going to do today is we're briefly going to introduce. We're just going to familiarize ourselves with the equations, and we're going to call it good. So we're going to look at the very first conic section, which is a parabola. Okay? A parabola, and we looked at that. That was the very first one we looked at in our activity. Is the set of all points in a plane that are the same distance from a given point called the focus and a given line called the directrix. So I have a diagram down there of what it looks like, and then we also have what is known as the axis of symmetry. So if you want to get that down, and then we'll talk about that and what those mean.
Like that graph thing.
It'd probably be a good idea to have the graph. Okay, so let's break down a little bit about what this definition means. It says the set of all points in a plane that are the same distance from a given point, the focus, and a given line called the directrix. So what that means is you're going to notice there's some points here, and I kind of erased them. What that definition means is that every point along this parabola, if I were to compare the distance from here to here, those are going to be exactly the same. And then likewise, that means if I were to pick a point here, the distance from the focus to that point and from that point to the directrix are going to be the exact same. So every point on that is how it's been graphed. So if I were to pick a point over here, right here, the distance from the focus to the directrix are the exact same. That's what a parabola is. And that's why it's so important, okay, where that focus is. And we'll talk a little bit about
How can you tell where the directrix goes?
the directrix is going to be this same distance from here to here.
So they'll give you one of them.
Yeah, yep. Or it might give you the length of some, and we'll talk about those in an example. So real quick, there are quite a few places where the parabola is. The Superdome in New Orleans, that's parabolic in shape at the top. Okay, so they are all a fixed distance apart. Another example of a parabola. Headlights or flashlights. Believe it or not, like in a headlight, wherever they put the light determines how bright that's going to be. The focus, if you put it at the focus, it will actually be the brightest of the light. And light rays are actually reflected from that light. They reflect back to the mirror, and then that's how they are reflected out. Okay, but a headlight, and this is the thing, if any of you ever want to try, take a headlight. If you're to slice that headlight down the middle, you're going to get a parabola as your shape. Trajectory of a baseball is parabolic in shape. From where you hit it, it's going to go to its peak point, and then it's going to gradually decrease. Okay. And trajectory of a rocket, and then suspension bridges. And notice here we have an example of a suspension bridge. Okay, if you guys don't know what a suspension bridge is, it usually goes something like this. And that's a parabola as well. So those are examples of parabolas. Now we have 4 different ways a parabola can open. Okay, a parabola can open up and down or left and right. So what I would like you to get down in your notes, and this is the last thing we're covering today, I just want you to write down this, and this is actually taken from your book, so this is a diagram in your book if you can't quite read it. But what you need to have down, okay, what are the crucial parts of this lesson right now are the equations. Okay, those equations, it is imperative you get those down. The P means something, the H means something, the K means something. And so where you find all of those is the vertex, the focus, the axis of symmetry, and the directrix. And like I said, this is the last thing we're doing today. I'm not going to have any homework for you tonight. All I want you to do is write this down. This is where we're picking up tomorrow. Okay? So those of you on the video, you're pretty much done for today. Okay? And so come back ready to go tomorrow.